The last chapter we did was on kinematics, which has to do with how things move. So in that chapter, we talked about velocity, we talked about acceleration, we talked about whether things are speeding up or slowing down. This chapter is on dynamics, which is not how things move, but why things move. And every time that an object is going to have a change in its motion, it is going to be due to some sort of a force on it. Now, if you're a Star Wars fan, you may be familiar with the phrase, the force be with you. We're not talking about that kind of force. The kind of force that we're discussing here is a force that is actually described as a push or a pull on an object. Now, sometimes students can think I literally have to be touching an object to push it or to pull on it, and we'll discuss that here in just a second. That's not true, that there actually has to be physical contact in order for there to be a force, although it can be true. So anytime that you're going to have a change in an object's motion, so in other words, if that object is going to be sitting at rest and you're going to start it moving, if it's at rest and you're going to stop it from moving, or if it's moving and it's going to turn a corner, or if it's moving and you're going to make it speed up, or it's moving and you're going to make it slow down, all of those are considered changes in motion, which we have also talked about as acceleration. And you'll remember that since acceleration is a vector quantity, it has to do not only with magnitude, whether it's going faster or slower, but it also has to do with direction. So if you're going north and you turn around and you go south, your object has been accelerated. It's a change in direction. It could also be a change in magnitude, could be both of them. The only way that a force can change an object's motion is if it is unbalanced. And I'm going to kind of leave you hanging right for the moment on exactly what that means. We're going to talk a whole lot more about that in another day or two. So just kind of hang on to that idea for the moment, and we'll get to it in a little while. The other concept that I want to get today is that there are two main types of forces. You can have either a contact force or you can have a field force. Now, like I alluded to earlier, a lot of times students think that if I say a push or pull on an object, I mean you actually are going to be physically touching the object. And that can be true. If I take my wagon and I pull it, or I get behind the wagon and I push it, that is a contact force because I'm actually touching the object that I'm moving. Tension on a rope is an example of a contact force. I'm not actually touching the object that I'm moving myself, but I'm exerting tension on it through a rope. Friction is another example of a contact force. You're familiar with if you go to scoot something along the floor or you go to pull something along the ground, you can't just give it a little tiny shove and it's going to do something because friction is going to stop it from moving. Thank goodness that we have friction, because otherwise it would be like walking around on ice all the time. And friction is going to be a topic that we're going to discuss in great detail in a few days as well. But friction is a contact force because it only happens when two surfaces are in contact with each other. Now, you can also have field forces, and those forces are forces that act at a distance, and it has to do with the area around an object. There are probably two main forces that you're going to be most familiar with. There are others. An electrical field force is an example. But magnetism, if you've ever played with magnets, you're probably familiar with the fact that if you go to put them together a certain way, like if I take these two magnets and I try to push them together this direction, I get them this close and I can feel that they're pushing back on each other and they don't want to touch each other unless I take this magnet and I flip it over, and in that case they'll stick together very nicely. So there is a magnetic field that surrounds that magnet that will either attract another magnet towards it or it will repel that magnet away from it. But you don't have to touch the magnet in order to experience the force of that magnet. Gravity is another example of a field force. You don't have to be touching the earth to fall to the earth. I mean, think about an airplane. If you're in an airplane flying high above the earth and something suddenly goes wrong with the airplane gets pulled back to the earth even though it's not touching it. So gravity is a field force. You don't have to be in contact with it in order to experience the pull of gravity. Gravity is actually it's actually the weakest force that we're familiar with. I know gravity seems like a really strong force to us because we know that we can't get away from the earth without a whole lot of expenditure of energy. However, when you start talking about electricity and magnetism and nuclear forces, those forces are all much, much stronger than gravity. So knowing how strong gravity is, that can tell you how strong some of those other forces are as well. Okay, so two big ideas for the day. First one is that a force is a push or a pull, and if that force is going to change an object's motion, it's going to be unbalanced. And then there are two types of forces: contact forces and field forces. Contact forces being forces that exist when an object touches another one. Field forces when those forces are actually exerted at a distance.